This is Josh White with JW Math Tutoring. Today's video is going to cover 11 problems from the October 2024 Digital SAT Math section. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin going over these 11 problems from the October 2024 Digital SAT Math Test, please keep a couple things in mind, and I say this at the start of all my videos. First, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications, and if you have any questions or comments, please do leave them below. Second, so these are problems that I've gathered primarily from the discussion thread on Reddit in the SAT subreddit. So these problems might not be exactly what you see, what you saw on the October test if you took it. Some of them I had to like change numbers to make them work. Some might be missing specific, details in them. Others I'm going to do as free response questions, even though on the test they might be multiple choice questions. So keep in mind that for some of these, there might be additional ways to solve them if they were multiple choice questions and you already have the answers in front of you. Okay? Even though I'm going to treat them as free response questions. All right. So with that, let's go ahead and get started. This is part 2. Be sure to check out part 1 if you haven't done so already, and also part 3 once it's released. Again, covering questions from the October 2024 Digital SAT test. Okay, question number 1. Here we have a right triangle, and first thing I'm going to do is just sketch out this right triangle, and I'm going to label the right angle down here x because it's given in the problem. Let's call this angle up here y and this angle z. Now we have line WX, which is perpendicular to YZ. Basically what we have here is a situation where we have a right triangle and we're just drawing an altitude to the hypotenuse. So there's our altitude. And you're also told, okay, WX is 531 and WY is 708. Find the value of tan Z. So there are actually at least 2, if not more, different ways to solve this problem. So, excuse me, one way is I went ahead and I said, okay, looking at this small triangle at the top here, XYW, okay, the tangent of angle Y is equal to its opposite side over its adjacent side. Therefore, Y is just equal to the arctan or inverse tan of that ratio. So if I go to Desmos and do that, that'll give me the measure of angle Y. And then Z is just going to be 90 degrees minus that. And then after that, I can just take the tan of angle Z and get my answer. So let me just slide this down here. Okay. So first thing I want to do is inverse tan of 531 divided by 708. Now I need to make sure I'm in degrees and not radians. Click the little wrench icon and then choose degrees. Okay, so there we go. It's 36.4. What I'm going to do next is I'm going to define this as y. That way I can carry through this value without having to worry about typing everything out and getting the exact value of it. So now, so if you want to write this down here, whatever, 36.86, dot, 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 dot. Okay, so now we know that y and z together add up to 90 degrees because, well, x is 90, so that leaves, the other 2 acute angles in your right triangle add up to 90 together. So z is just going to be 90 minus y. All right, so we'll go back to Desmos, and we'll just do that. All right, so there is z. I'm also going to define this as z. So z is 53.13, just again approximately. Now we're just going to do the tangent of that. And this again we'll go to Desmos to do. So next line, tan of capital Z. All right, so it gives me 1.33333. Notice that doesn't match our answer choices, which are fractions, but all we have to do is just hit this little button. Okay, there it is, 4/3. Correct answer is going to be A. All right, so this is method one or approach one, we'll call it. All right, alternate solution method that you could use. Excuse me. Next, you could go ahead and notice that the tangent of angle Z is going to equal, let me just make sure I get this right, xy over xz. Okay, so in other words, if you look at the whole large triangle here, okay, tangent of angle Z is equal to its opposite side, xy, over its adjacent side, xz. All right, notice from the picture, this is basically like short leg over long leg, just the way that I've drawn it. So now, if you look at the small triangle, the yellow triangle, basically you set up the ratio in that triangle of the same corresponding sides, which is going to be right here. Even though it doesn't like it, like I'm just going based on the drawing of the picture, but it's even like it's not going to be short leg and long leg because 708 is longer or larger than 531. So basically, it's going to correspond to 708 over 531. And if you just go ahead and divide those out, you'll see that they're just equal to 4/3. See, again, it's 1.33333, or right there, 4/3. All right, so what I'm doing here is when you have a right triangle and you draw an altitude to the hypotenuse, which is what XW is, it splits the large right triangle into two smaller right triangles. All three of the triangles are similar to each other, okay? So just to show you basically what I'm doing here, so like we know that this angle is 38.86. We found it previously, but whatever. Just I'm just going to use this thing because that's the actual value. And we know this is 53.13. So what happens is this is also 53.13 and this is also 38.86. Let me just double check. Am I writing that correctly? No, it's 36.86. What am I doing? Not 38. Get rid of this. 36. 36. 36. Okay. So you have the large overall triangle, okay? Z, X, Y. Down here you've got the 53. Up here we got the 36. Whatever, ignoring the decimals. Okay, then we have this small yellow triangle, okay? And I'm going to draw the same orientation. So here's the right angle at W. Notice X is down here at angle X is the 53 angle. So X is down here and it's 53, and then Y is up here, okay, and it's 36. So notice in these two triangles, basically the tangent of Z right here, okay, corresponds to this side, whatever that's across from it, which is XY, and then over, this side down here, which is XZ. So the same thing is going to be true because they're similar. All these triangles are similar. So the sides are going to be proportional. So the tangent of this 53 is going to be the same. In other words, this side over this side, opposite over adjacent, it's going to have the same ratio as this side over this side. The values obviously aren't the same, but the point is the tangent, the ratios of the trig functions, the ratios of the sides are the same because they are all similar triangles. We know they're similar triangles because notice we have, you only need two pairs of congruent angles, but we technically have three. All right. So the whole point is the tangent of angle Z, looking at the triangle to the left, is yx over xz. Okay. Xy over xz, whatever you want to call it. We can get rid of the short leg and long leg since we know that technically it's actually the opposite of that. And that will be the same as the ratio of the tangent for the other triangle. In other words, this side to this side will have the same ratio as this side to this side. okay? And this side over this side is just equal to the tangent of z, which is what we're looking for, and therefore it will be the same as the ratio of this side to this side, which we already know. That's the 708 to the 531, okay? So therefore, this is an alternate method that you could use to get it by setting up similar triangles, and you get the exact same answer of 4/3. Okay, sorry, it's a long explanation to go through that and just talk about how the similar triangles work. All right, question number 2. Here we have another rectangular prism problem. Got a square base. Okay, whatever, looks something like this. We know its total surface area. We know the area of the 4 non-base sides. So that means the 4, kind of like vertical sides in my picture. Front, back, left, and right. And they want to know the height of the prism. Okay, so basically what we have here is square base. This is x and x. This is h, let's say. So we know that x squared, area of the base, times 2, because there's 2 bases, plus x times h, the area of one non-base side, and then times 4, because there's 4 of them, and they're each going to be the same because the base is square. In total equals 550. However, we also know that this quantity is equal to 308. So notice if we plug that in, we get 2x squared equals 550 minus 308, which is 242, or x squared equals 121, just dividing by 2 on both sides. Therefore, we get 11 for each side of the square base. So now all you have to do is basically you could plug it into the entire expression to solve for h, but I think it's easier to just, use the fact that 4 times 11 times h is equal to 308. The 4 non-base sides, their total area. And then you get 44h equals 308. H should be equal to 7. So let's just confirm this. In Desmos, make sure we did the calculations correctly. So first of all, we have 2 times, I said the base sides were each 11, and then we've got 4 times 11 times 7. Okay, that adds up to 550, and just this part adds up to 308. So yes, we got the right values. So the height for this rectangular prism is just 7 centimeters. All right, below that, we have a word problem involving percentages. So what's going on here is you have the muscle mass, okay, 134.8 kilograms, and that's equal to about 67.2% of the overall mass. So you set up an equation, 134.8 is, and then you 67.2%, convert that to a decimal, and then x is our overall mass. So you just solve this for x, divide by 0.672. And I'm going to do this all in Desmos. It's going to be just so we carry the exact values through. All right, so the overall mass, which I'm going to call M, which is going to be equal to 134.8 divided by 0.672. All right, so we have it right there. Let me just also scroll up so it's a little bit easier to see this. Okay, next. What we need to do is figure out the remaining mass taking away the muscle mass, meaning how much of the remaining mass, which is part that's divided into bone and fat, what that actual number is. So I'm just going to take the M value and subtract the 134.8. And I'm going to call this R for remaining. Okay, so again, I subtracted 134.8, and the remaining mass is just going to be equal to, again, we just need to approximate 65.79. All right, so this is bone and fat, the total mass of both. Now we need to find 56% of this to find the total mass of the bone. So we're going to multiply this by 0.566. That's going to give us the bone mass. So now I'm going to take, define that as B. So I'm going to take R times 0.566. Okay, so bone mass is 37.24 approximately. 37.24. That is the bone mass. Now I'm going to subtract this minus that, and that's going to give me the fat mass. Because ultimately we'll need that figure to get our final overall answer. So now I want to take the, and I'm going to call this F for fat mass, the remaining amount, the R, minus the bone mass. Okay, we get 28.55. So the fat mass is about 28.55 kilograms. Now we need to know the nearest tenth of percentage, the fat composition of the overall mass. So all we're doing now is we're taking the 28.55 and dividing that by the overall mass, the 200.959. So now I'm just going to take F divided by M. Remember, M is what I defined as the overall mass at the beginning. Okay, now just multiply by 100 to get it into a percentage. So this is, let's see here, 14.2352. 14.2352. All right, so round it to the nearest tenth of a percentage, it's going to be 14.2%. So in this question, not sure if this is multiple choice or if it would be a grid in, but 14.2% is the percentage of the overall body mass of this buffalo, which is comprised of fat. All right, next question. We have one here that looks looks fairly complicated, but it actually is not that difficult. So you're given this function with some absolute value signs and whatever a and b, they're constants. You're also told that like when you plug in 547, you get some number. When you plug in negative 533, you get some other number, h and k, okay, whatever. And they want to know what's the value of this expression here. So first I will show you just how you can do this in Desmos and figure it out entirely in that, and then I'll talk a little bit about the theory for why it works out like that. Let me slide this over. Okay, so first thing I'm going to do is I'm going to define my function. Okay, and I got to add sliders for A and B. Now A has to be greater than B, and they both have to be greater than 65. So let's go 67, and let's go 66. They don't have to be integers, but whatever, that's fine. Okay. So now I'm going to say H equals F of, let's do it this way. H equals F of 547. Okay, it's some gigantic number, but it actually doesn't matter what it is. K equals F of negative 533. Just so far, notice H and K are identical. Okay, just make a note of that. I'll talk about that in a little bit. Now, okay, what's the value of 7 times 547 to the H? Hold on, I gotta type it like this. H minus K plus negative 533 to the H minus K. All right, so what is the correct answer? The correct answer is 8. All right, and you can do the entire thing in Desmos. Now, here's the theory behind this, or here's what's actually going on or what's actually happening. All right, basically, when you plug in 547 for x in these, inside the absolute value, you get 540. Okay, and then the absolute value of 540 is just 540, and then it works out the problem based on what A is and what B is and blah, blah, whatever, and it gives you some number. However, when you plug in negative 533, negative 533 minus 7 is negative 540. And so, but the absolute value then turns it to positive 540. So the point is, H and K end up equaling each other because you have the same, like the absolute value gives you the same expression. It's basically like A times 540 squared minus 65 times 540 plus b, and whatever a and b are. That it's the same value for both of them. Therefore, h and k are the same number. So h minus k just becomes 0, and h minus k just becomes 0. So then this whole thing just becomes 7 times 547 to the 7 times 1, and then this is 0 is just plus 1. 7 plus 1 equals 8, okay? And that's basically kind of like the theory behind it. But again, you could go to Desmos, you can plug the entire thing in there. All right, next one. This one is actually a repeat. This one I did cover on my August problem set. I forget which one it was on, to be honest with you, but I will show you again how you could do this both by algebraically and also how you could do it entirely in Desmos. By the way, one thing you can do, you can technically just like divide everything by 48 and then it would drop out and it just becomes 1 over q, 1 over p, plus 1 over r, plus 1 over s. So you can do it if you want to, but you technically don't have to. But the answer choices are not going to have like all the 48s in them. So if you want to do this algebraically, technically what you're going to do, you're going to have to multiply both sides by a common denominator of QPRS. And then it's like you're going to end up with a bunch of terms that have 3 letters. It's just the letter on the bottom is not going to be there. So on the left, it's going to be PRS. On the right, the first one's going to be QRS. The middle one here, again, we're multiplying by all 3 of these, is going to be QPS. And the last one's going to be QPR. Since you're solving for Q, you need all of the Q terms on the same side. They already are on the right side. So then you can factor a Q out and you get RS plus PS plus PR. And then you just divide by that on both sides. RS plus PS plus PR. So your answer is basically going to be this right here. If it's, this obviously is multiple choice, so it would probably have Q equals on the left side instead of equal to Q, but you get the idea. PRS over RS plus PS plus PR. This is algebraically how you could do it. Now I will show you how to do this in Desmos. Basically what we're going to do is I'm going to type the original problem, except first of all, again, you can get rid of like the 48s, or you can keep them there. It technically doesn't matter. All right, except the letter I am solving for, which in this case is Q, I'm going to replace with Y. All right, the other 3 things I'm just going to add, I'm going to add sliders for, and I'll just move them to whatever random numbers here. There we go, perfect. Now what you would do is you would go through and you would type all of your answer choices. And you would see which one matches the line. So for example, instead of Q equals, it would be Y equals. So for example, the actual answer choice is RS plus PS plus PR. So notice this is perfectly overlapping the line that you're given. Okay, and if you had another answer choice, say it was like, I don't know, like say you just flipped it. You just thought you could flip everything. And it was like P plus R plus S. Like you can see clearly that's not overlapping it. That's not the same line. Therefore, it's not equivalent to it or not equal to it. So that one's wrong. Or if you had to say something like this. You can see right here, this clearly does not overlap the horizontal line that we're looking for, so this is clearly wrong. But you'd go through all 4 answer choices, you'd type them each in, and you would see which one completely overlaps, which one has the same exact value as the original, line, the original problem that you first graphed. All right, next up, we have a quadratic function problem. And basically what's happening is you're launching this ball into the air, from the ground. It reaches its maximum height of 36 feet, up here after 1.4 seconds. So hopefully you know that this is going to be the vertex. This 1.4 comma 36 is going to represent our vertex. So that means if we're looking at vertex form, the 1.4 is going to be h, the 36 is going to be k, the 36 is going to be positive, so we're looking for something with plus 36. Okay, so they all have that, so that doesn't help us. Also, because this quadratic function, because the path of this ball is going down because that's a maximum, that means that the a value must be less than 0 or negative. So we can get rid of a, we can get rid of c, and you're down to b versus d. And then in here, because this time value, 1.4 seconds, is positive, it's going to be x minus 1.4. So the correct answer for this one is just going to be letter B. Now, you could also, if you wanted to, if you weren't sure, you could just go to Desmos and you could graph out these answer choices. So if you look at this first one, I mean it's crossed out now, but if you graph this first one, basically you can see that yes, it has this vertex here, but this is not its maximum height. This is its minimum height. So that one's obviously wrong. And if you graphed out C and you made it like this, again, here it doesn't have a maximum, it has a minimum. So again, it's wrong. Same thing if you looked at D, put the negative in front here. Okay, it now has a maximum, but the maximum is not at 1.4 seconds. The maximum's at negative 1.4 seconds, which, doesn't make sense because time is never negative. So you could also get the answer, by just going to Desmos and doing that. All right, next up, question number 7. So here we have a quadratic equation where it tells us it has no real solutions. B is an integer value, and they want to know what's the maximum value of it. So traditional way to do this is to go ahead and set up the discriminant quadratic formula. It should be b squared minus 4ac. Okay, b is just b, so that part doesn't change. Minus 4 times negative 4 times negative 36. For it to have no real solutions, we need this to be less than 0, or in other words, need it to be negative. So we get b squared minus 576 is less than 0. B squared is less than 576. Technically, the way you solve this is you set it equal to 0 and you get your critical points, which would be like essentially this, square root both sides, and you get 24, and then you technically go on a number line. Well, it's plus or minus 24. Negative 24, positive 24. And basically what you're going to see is if you pick a number that's between these, like pick 0 and plug in 0, well, 0 squared is 0, minus 576 is less than 0. So this is going to be negative, and like out here, it's going to be positive. So essentially, the values we're looking at are the ones here in between negative 24 and positive 24. So what is the maximum value of B? Notice, it is not going to be 24 because if it was 24, then it would be exactly equal to 0. And that would mean that there is one real solution. But we don't want it equal, we want it less than. Therefore, the maximum value will be 23. Okay, so the correct answer for this is going to be 23. Also, you could just go to Desmos, plot it out, use a slider. So notice, basically, all I'm going to do is keep moving it until, okay, so notice here I now have real solutions, so I'm too high. Notice 24, there is a real solution. So therefore, the maximum value is going to be the next integer below that, which has to be 23. Okay, so that just confirms correct answer is 23. Next up, question number 8. Here we have an exponential function of the form, c to the x, where c is a positive constant, and they tell us that the y value for evaluating this at 5 is equal to 49 times the y value you get when you evaluate it at 3. So there's a couple of different ways you could think of this. One way to think of it would be, okay, if you plug in 5, that's c to the 5th. That's equal to 49 times plugging in 3, which is c to the third. Since we know c is a positive constant, we can technically divide by it since we know it's not equal to 0. Therefore, c squared is equal to 49. Now, technically you would square root both sides and you would do plus minus, but again, it can only be the positive 7 because it's not going to be negative 7 because, again, right here, c is a positive constant. So, therefore, the value of c is 7. So this is one way to find it or think about it. The other way is, if you think about it, make like a little XY chart here. 3, 4, 5. Okay, so you're at 3, and your Y value for that is just f of 3, right? And then when you multiply by, like when you go to plug in 4, essentially you're going to be end up multiplying by C another time, one time, and then you're going to be multiplying it by C twice, down here, this f of 5, so you multiply by C once and by C a second time. So it's like, what number do you multiply by twice to end up with 49? Because you're starting with this and then you do it once and twice and you get the 49 in front. Well, times 7 times 7. So that's just an alternate way kind of think about it, but the correct answer for this, C, is positive 7. Okay, question number 9, trig problem here. You're told that y is 21 degrees and you're told sine x over cosine y is equal to 1. What's the measure of angle x? So there's multiple ways you could do this. You could say, okay, sine x over cosine 21 is equal to 1. Therefore, sine x is equal to cosine 21. Actually, let me do this with just generic things and I'll put the 21 in, sorry, in a little bit. Just keep this as y for right now. Okay, so basically this is true. The sine of one angle is equal to the cosine of a different angle when these two angles are complements. In other words, x is going to have to equal 90 minus y in order for this relationship to be true. Therefore, x is going to have to be 90 minus 21, which would be 69, which is the correct answer, in order for the sine of the specific x value to equal the cosine of y. So now, you could go to Desmos, and you could just confirm this. Right there, notice we have the exact same values for each of them, right? So that's one way to do this. I mean, obviously, alternate way to do this as well. Go to Desmos. You could do this. And then yes, we're in degrees. Okay. So the thing is, there's technically going to be two different values here when it tries to solve this equation. But the 69 degree one, the one you can see right here, the 69 degrees, is just the one. Let me see. Will it let me? Yeah, right here. It won't let me click on the intersection point, unfortunately. But let me just see here. Let's say if we do this. Yes, right here. Now it lets me click. Now it lets me click on it. Okay, so you can see right there the value for x that you can get is just 69 degrees, and that's how you could basically solve this just completely in Desmos without needing to know, without recognizing the fact about the two angles needing to be complementary, in order for the sine of one to equal the cosine of the other. All right, next up, question number 10. Here we have two functions, and it wants to know which of these displays the y-intercept of the function as a constant or coefficient in the function for x is greater than or equal to 0, where a and b are positive constants. So for this one, the easiest way, I think, is just go straight to Desmos. and graph them each out. Okay, so the first one, we'll add the sliders just in a second. Okay, so they're positive constants, so just whatever. There we go. All right, let me go back to the home thing here. Also notice you can set a restriction on the graph. So I'm going to restrict this to just, x is greater than or equal to 0, which is what the it says in the problem, basically for the domain. All right, so one of these has 4.8. The other one has 39.423. So again, 4.8, 39.423. Now, do we see, like, if I just replace the A's here with the 2 that's equal to, and I replace the B with 2.8, 2.8, do I see a constant, meaning just a number added with no variable on it, added or subtracted in the problem anywhere? Do I see 4.8 or 39.423? No. Do I see a coefficient, meaning a number in front of a variable or in front of, like, a base constant being raised to a variable? And the answer is no, I do not. I do not see 4.8, anywhere. I do not see 39.423 anywhere. So therefore, based on, what you're given in this problem, the answer should be D, none of the above. Finally, last question, number 11. So let's say you have a data set and it's got the 11 numbers listed here, and then it adds one more value, much, much larger value, 85, to it. And it wants to know which of the following is true. So in other words, what's going to change the mean, the median, both, none? So obviously the mean will increase, okay, because currently you're taking the average of a bunch of numbers between 10 and 20. So the median is going to be somewhere, in the middle there. And then when you add 85 to it, well, that's going to cause it to go up. So the mean is going to increase. We can get rid of this. The mean will not change. Mean will not change. Now the median for the original data set, the 11 numbers, so it would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is the number right in the middle for our median. When we add 85, now what's going to happen is we're going to cross out basically 1, 2, 3, 4. Okay, so we got 85, 1, 2, 3, 4. 1, 2, 3, 4. What am I missing here? How am I still 1, 2, 3, 4, 5? Oh, sorry, I missed this one. There we go. So now we are left with two numbers in the middle. So therefore, our median is the average of these two values. Let's just check again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So the average of these two numbers is just 15. Therefore, the median does not change. So the correct answer for this is going to be letter B. Again, you could just do all this in Desmos too, so I'll just confirm it there. So the original mean 10, 11, 12, 13, 15, 15, 15, 17, 18, 19, 20. Okay, so that's the original mean. Now when I add 85, okay, notice it obviously goes up to 20.83 from 15. So the mean increases. Now, here's the original median of 15 and then comma 85. Oh, median is still 15. Median doesn't change. All right, so that was 11 more questions from the October 2024 Digital SAT Math exam. I hope you enjoyed this video. Please do click the thumbs up, subscribe to my channel and sign up for notifications. Also be sure to check out part 1 from the October 2024 test if you haven't done so already. And also check out part 3 once it's released as well. If you have any questions or comments, please do leave them below, or alternate solutions methods to any of these problems as well. Otherwise, again, I'll be back soon with more digital SAT math related content.